Welcome back to iOS Expert. The last step in polishing Cat Fancy is to add 16 unit test files. When I complete the features of a coding challenge, I create a unit test file for every unit testable source file. In this video, I'll show you that process for Cat Fancy. To reduce wordiness, I will use some shorthand, which I describe now. When I say something like create a file foodtests.swift in group bar, I mean create a unit test file called foodtests.swift in the bar group of the Cat Fancy tests group. For every file, I'll talk about what needs to be unit tested. Then I'll tell you to create the unit test file and grab its code from the snippets file or type its code from the screen. In the interest of time, I won't describe every line in every unit test file. Most of the unit testing code is self-explanatory, and the mechanics of unit testing are not the focus of this course. I will call out coding practices in certain unit test files that may interest you. But my primary goal in this section of the course is to share my thought process for unit test creation, which consists primarily of deciding what to unit test. This is breedsloader.swift. The one behavior to unit test is that it loads the expected number of breeds. In the helpers group, create a file called breedsloadertests.swift. If you get a pop-up about a bridging header, click Don't Create. Give it these contents, snippet 40. Different URLs return different breed counts, so this line ensures that 19 will be returned. Mockdata.breednames contains exactly 19 breeds. Better not to repeat the number 19 here, since it's already implied by the size of that array. This is gettersetterfake.swift. There are three behaviors to test: initializing with a dictionary, getting a value from the dictionary, and setting a value in the dictionary. In the helpers group, create a file called gettersetterfaketests.swift. Give it these contents, snippet 41. You may notice some emoji in this file. Writing unit tests is not my favorite aspect of software development, but I find that emoji make the process fun. This is gettersetterreal.swift. There are two behaviors to test: getting a value from user defaults and saving a value to user defaults. In the helpers group, create a file called gettersetterrealtests.swift. Give it these contents, snippet 42. Because this test function writes to, and could potentially rely on, the contents of user defaults, care must be taken. Cat Fancy doesn't use a user defaults key named key in production, so this test function has no dependencies or unwanted side effects. This is imageloader.swift. There are two functions to test: fetch and setSession. The unit test for fetch should verify both happy path and error behavior. In the helpers group, create a file called imageloadertests.swift. Give it these contents, snippet 43. The one tricky thing about writing the test fetch function was figuring out how to compare two UI images for equality. The PNG data API, I learned, enables this comparison. Test setSession doesn't call setSession directly, instead changing the session type setting, which triggers a call to setSession. This is soundplayerDummy.swift. There's no behavior that can be tested via XCT asserts, but there is still value in unit testing. Unit tests will increase code coverage and, in the unlikely event that someone introduces a bug into SoundPlayer Dummy that causes it to crash, unit tests can catch that. In the helpers group, create a file called soundplayerdummytests.swift. Give it these contents, snippet 44. Note that the function just exercises SoundPlayer Dummy, increasing code coverage and sniffing out potential crashes. No XCT asserts. This is SoundPlayerReal.swift. As in SoundPlayer Dummy, there's no behavior that can be tested via XCT asserts, but there is still the same value in unit testing. In the helpers group, create a file called soundplayerrealtests.swift. Give it these contents, snippet 45. Note that the function just exercises SoundPlayerReal, increasing code coverage and sniffing out potential crashes. No XCT asserts. There is an argument that SoundPlayerReal shouldn't be unit tested because the presence of sounds during unit test runs is potentially annoying. But for me, the test coverage and crash sniffing benefits outweigh the annoyance. This is URL extension.swift. The unit test should verify that could not init returns the expected string. In the helpers group, create a file called URL extension tests.swift. Give it these contents, snippet 46. This unit test is simple, but effective and cat-friendly. This is URL protocol stub.swift. URL session.stub uses this conformance to stub API calls. There are 3 functions with behavior to unit test. 2 of the functions are easy to unit test. Can init needs verification that it returns true. Canonical request needs verification that it returns the URL request passed in. Start loading is trickier. The important behavior to verify is that it calls the function URL protocol client did load, passing the JSON data from the bundle as an argument. In the helpers group, create a file called URL protocol stub tests.swift. Give it these contents, snippet 47. These are the straightforward unit tests. This unit test is not as straightforward. To explain it, I'll work backwards. This line runs the function being tested. This line initializes the URL protocol stub, passing a SPY test double as the URL protocol client. This line initializes the SPY with a closure saying what to do when the SPY's loaded data function is called, in particular verify that the data passed in is the JSON data from the bundle. This is URL session extension.swift, which has a stub test double replacement for URL session.shared. There are 2 things to unit test in this file. The first is to verify that URL datadict has a specific key value pair corresponding to a URL and JSON data from the bundle. The second is to verify that the sessions, configurations, protocol classes consist of a URL protocol stub. To accomplish these verifications, create URL session extension tests.swift in the helpers group. Give it these contents, snippet 48. This is breeds_url.swift. There are 2 things to verify in this file, that the 4 URLs have the correct values, and that they have the correct display names. In the models group, create a file called breeds_url_tests.swift. Give it these contents, snippet 49. Straightforward. This is breed.swift. There's currently nothing testable in this file, but browse breeds viewModel tests will need breed to be equatable, so let's take care of that now. At the top of the breed definition, add equatable conformance. Just before the closing brace of the definition, add the function in snippet 50. In the models group, create a file called breedtests.swift. Give it these contents, snippet 51. Also straightforward. This is license.swift. The unit test should verify that each enum case has the correct license URL associated with it. In the models group, create a file called licensetests.swift. Give it these contents, snippet 52. There are 7 license enum cases, so you might expect to see 7 XCT asserts here. I would find writing 7 similar XCT asserts in a row annoyingly repetitive. Using this literal array of 7 tuples, each with an enum case and the expected URL string, I use just one XCT assert, which strikes me as more elegant. This is settings.swift. Unit tests should verify that changing the 3 settings has the effect of actually changing them. As a bonus, the unit tests can also verify that default values for the settings are correct. In the models group, create a file called settingstests.swift. Give it these contents, snippet 53. Note that because this and the other test functions use a getter-setter-fake test double, they do not clobber or depend on the state of user defaults, where settings are stored in production. This is sortorder.swift. Unit tests should verify the correctness of display names and sorting. In the models group, create a file called sortordertests.swift. Give it these contents, snippet 54. The 42 is an Easter egg for fans of Douglas Adams. This is world.swift. Unit tests should verify that the 2 static instances of world, production and unit test, have the appropriate conformances, production or test double. In the models group, create a file called worldtests.swift. Give it these contents, snippet 55. This is browse breeds viewModel. Unit tests should confirm the following. 1. State starts as .loading. 2. When the breeds URL is .with more, a call to load breeds changes state to .loaded and 19 breeds are returned. 3. When the breeds URL is .malformed, a call to load breeds changes state to .error. 4. When the breeds URL is .empty, a call to load breeds changes state to .loaded, and an empty array of breeds is returned. In the viewModel group, create a file called browseBreedsViewModelTests.swift. Give it these contents, snippet 56. There is a build error because state is not currently equatable. Open browseBreedsViewModel.swift. Add equatable conformance to the state enum. The code you added to breed.swift a few minutes ago enabled this conformance. Go back to browseBreedsViewModelTests.swift. The build error is gone. That's it for unit tests. Run all of them by clicking the test navigator and then catfancy auto-created. Click the Report Navigator. CatFancy's unit test coverage is 34%. Not as high as in its UI kit cousin, CatFancy with a C, but still respectable. Implementation of the SwiftUI version of the coding challenge is almost complete. In the final section of this course, you will add a README and launch screen. If you have accepted my challenge to implement your own model SwiftUI solution, now is a good time to enhance that solution by making it unit testable and then by adding unit tests.